ask us if it makes sense to interpret the y-intercept. So the y-intercept is when x is 0, so x is our literacy rate. We're saying, does it make sense for your x to be 0, your literacy rate to be 0? Technically it could, like in real life, but the way this is set up, they tell you that x has to be between 19 and 100. So this model doesn't apply when x is 0. So we'll say, no, we can't interpret the y-intercept for this one because 0. This one says a y value of 0. We don't want the y value to be 0. We want the x value to be 0. So we want an x value of 0 to be outside the scope of the model because they're restricting our x's to between 19 and 100. So 0 is not included in there. So we'll select that one for that question. And then again with the predicting, anytime they ask you to predict, that means you're going to use the least squares regression line. You're going to plug in your x value. So this is 11B. Nope, C. So we're predicting it where there's a 37% literacy rate. So in that case, our x is 37. Just to double check, that falls in our interval right here, so it's okay to use x equals 37. If they asked us to use something like x equals 12, we couldn't do that because that's not in our interval. But this is in our interval, it's okay, we can go ahead and plug this in. So we'll get y hat equals negative 0.0527 times 37 plus 8.1. And I get 6.1501. And I'm rounding to one decimal place, so that would round to 6.2. Okay, and then they ask, would it make sense to use this model to predict the age difference between husband and wife in a country where the literacy rate is 10? So for part D, again, your literacy rate is your x, so in this case, x is 10%. So notice 10 doesn't fall in between 19 and 100, so we can't use this model because our x is not in that range. So in this case, we'll say no, it does not make sense because an x value of 10 is outside the scope of the model because the x's are the only things kind of being restricted in this case. So in this case, our x value of 10 is outside the scope. Y values, we really don't care because we don't know what the y value is because we need to plug it into the formula to figure that out anyway. Okay. So they tell you the literacy rate is 97%, and the age difference between husbands and wives is 2 years. And they ask you, is this age difference above or below the average? So what we're going to do for part E, my literacy rate, which is x, is 97%, right? And my y, the difference between the two, is going to be a positive 2. And so that's my actual observed value. So what I need to do to see if it's above or below average is I need to figure out what the predicted value is. So for this one, whenever they say, so for this one, for the average, that's the same thing as the predicted, which means we're going to use the least squares regression line for this one. And so when we use our least squares regression line, we're going to plug in our x value, which happens to be 97. We're going to put that into the formula. We're never going to put a y value into our formula and solve for x. We always only substitute the x in. So we get y hat equals negative 0.0527 times 97 plus 8.1. 2.9881. This one. So my average would be 2.9881. So my observed value over there was actually 2 for my y. So is my observed value below or above average? Below, because it's smaller. So 2 is smaller than my average, so it's below average. It's below average because the age difference should be this number that I found over there, and if I round it to 1 decimal place, I don't want to do 2.9, I'm going to round it up and it's going to be 2.0. So anytime they ask you to predict, you're going to use the least squares regression line. If they ask you about the average, that's the same thing as the predicted value, which is using your least squares regression line. Other questions for this one? Yeah. 16. Number 16. Yes, I think we did this one last time. So this one you don't actually have to put it in your calculator because they actually give you the value for you. So you could put it in, and when you do, you should get this value back for your coefficient of determination. So if you know your coefficient of determination is 97.6, that tells you by definition of what the coefficient of determination is. It means that the amount of your variability in your y value that's explained by the least squares regression line is the same thing as this number up here. So here it says the least squares regression line explains, and this is going to be the same thing as your coefficient of determination, which is 97.6. Of the variation in, and then we're always looking at the variation in our y values, not our x values. So if we look at our y values, that's going to be the length of the eruption. So we'll go down here and choose length of the eruption because that's my y value. You don't want the time between eruptions because that's your x. So for this one, you'll always select your y value and go with length of eruption. Other questions? Alright, so this is going to be due tonight along with the quiz. The quiz should be very similar to the homework.